Hi everyone. Today we're going to study integral tests for convergence. Let a sub 1 plus a sub 2 plus a sub 3 plus and so on up to plus a sub n plus and so on equals the summation from k equals 1 up to infinity of a sub k. Be the given infinite series. Suppose that a sub n equals the function f of n, where f is a continuous positive function. Then the series summation from n equals 1 up to infinity of a sub n converges or diverges according as the definite integral from 1 to infinity of f of x dx is convergent or divergent respectively. Let's have example 1. Use integral test to determine whether the series summation from n equals 1 up to infinity of 1 all over n times square root of n is convergent or divergent. Our a sub n here is equal to this value here, the fraction 1 over n times square root of n. This is the function with respect to n, or f of n. By integral test, we say that it is the definite integral from 1 to infinity of this f of x dx. So with respect to f of x, we're going to copy this fraction and we will change the variable n into x. So we have now the definite integral from 1 to infinity of the fraction 1 all over x times square root of x, then dx. Now let us simplify the radical by showing this to be a fractional exponent. So the square root becomes 1/2. So x times x raised to 1/2 will be x raised to 3/2. Then we can show this fraction into x raised to a negative 3 over 2. Now let us evaluate the integral. So we have now x raised to negative 1/2 all over negative 1/2. We can simplify this by flipping the fraction in the denominator. So we have now this negative 2 times x raised to negative 1/2. We can simplify this further by putting the radical. So we have negative 2 all over square root of x. Now let us evaluate with respect to the limits from 1 up to infinity. So we have now the first fraction to be negative 2 all over square root of infinity minus minus 2 all over square root of 1. In the first fraction here, the square root of infinity will grow bigger and bigger, will come to 0. So it seems that this value is cancelled. And then the negative of negative 2 all over square root of 1 is now equal to positive 2. Since the integral comes to a value 2, we say that this integral is convergent. Now, since the integral converges to 2, the series given here is also convergent. Example 2. Use integral test to determine whether the series, the summation from n equals 1 up to infinity of the fraction 5 over n plus 1 is convergent or divergent. Our a sub n is equal to this fraction 5 over n plus 1. We say that this is a function with respect to n. By integral test, we have the integral from 1 to infinity of f of x dx. Considering the fraction here, we will now write the integral from 1 to infinity of the fraction 5 over the quantity x plus 1, then dx. Using substitution method, we let u equals x plus 1. So this integral will be 5 times the definite integral from 1 to infinity, 1 over u times du. We know that this 1 over u will give us the natural log value. So that will be ln of u. Then let us return the value of u in terms of x. So we have 5 times the natural log or ln of absolute value x plus 1. Then let us evaluate this with respect to 1 up to infinity. So the first group will be like this: 5 times ln of the absolute value infinity plus 1 minus the second group 5 times ln of absolute value of 1 plus 1. In the first group here, the infinity plus 1 will simply be infinity, and the ln of infinity will be a big number. So this first group will just be simplified into infinity minus the second group. 1 plus 1 is simply 2. See here that the 5 times the ln of 2 is simply a constant. So infinity minus a constant will just simply be infinity. Since the value here is infinity, it means that the integral here is divergent. Now we say that since the integral diverges, the series given here is also divergent. This is the final answer. I hope you learned something from this video. See you again next time.